I'm Naswa, and I would like to give a little bit introduction about what is error in experimental data. So as we know, collecting and interpreting data is key in any lab work. Lab give a quick overview of how to estimate and analyze experimental error. While detailed errors analysis isn't required in our report, understanding the basic is really important for accurate reporting. So as you know, in science, especially in chemistry, when we do experiment, we measure things like volume, mass, concentration, and other. So error in experimental data means that the value that we measure not perfectly accurate. Yeah, they may be a slight off from the true or expected value, but this doesn't necessarily mean a mistake was made. Sometimes the mistake comes from apparatus itself, which is can lead to error. So it's just that no measurement is ever exactly perfect. So as you know, in science, especially in chemistry, when we do experiment, we measure things like volume, mass, concentration, and other. So by understanding this error, we can help the chemists to improve their method and skills, and we can make sure the results are trustworthy. Besides, in this experimental data, we have three types of error that occur. The first one is systematic error, the second one is random error, and the third one is gross error. So for the systematic error is an error that happens consistently and repeatable due to the improper methods and faulty equipment. Next is a random error. Random error is the error that happens unpredictably due to the small factors like temperature and human reaction time. So last but not least is a gross error, or we call it as a human error. This error is a really big mistake that usually happen in this experiment, like choosing the wrong samples, spilling a sample, or reading a measurement incorrectly. Yeah, so I think that's the end of my part. Now let's move to the next part. So, by understanding this error, we can help the chemists to improve their method and skills, and we can make sure the results are trustworthy. Besides, in this experimental data, we have three types of error that occur. The first one is
Hi, I'm Sita binti Azman. I will present about accuracy and precision. Accuracy and precision are two important concepts in measurement. Accuracy is a closeness of a measured value to the accepted value. For example, if the actual weight of an object is 10 grams and you still reach 10.1 gram, is accurate because it's close to the true value. While for the precision is the degree of the agreement between replicate measurement of the same quantity. Repeatability of a result expressed as a standard deviation, the coefficient of variation, the range of the data or confidence interval about the mean value. For example, if you weigh the same object 5 times and get 9.8 gram each time, the results are precise. They are consistent even though they are not accurate. You can imagine that you are shooting error at a bullseye. First, low accuracy and high precision. Errors scattered randomly and far from the bullseye. Second, high accuracy and low precision. Errors are spread out by average around the bullseye. Third, low accuracy and high precision. Errors hit the same spot but far from the bullseye. And lastly, both high accuracy and high precision. Error tightly grouped at the bullseye. Okay, so we already described about accuracy and precision, but how error affect the accuracy and precision? Error affect accuracy and precision by determining systematic errors, which is accuracy. Second, indeterminate, random or accidentally errors, precision. And lastly, gross error, accuracy and precision.
I will present about the types of error in chemical analysis. There are three types, which is systematic error, indeterminate or random error, and gross error. Let's go through them one by one. I will present about the types of error in chemical. First, systematic error is a constant error that originates from a fixed cause. It is affect the mean of the set data to differ from the accepted value. The results are either high every time or low every time compared to the true value. example, estimation of pointer between two subdivision or color of solution. For method error, it is considered as the most serious error. For example, chemicals or reagents used in experiment are unstable, incomplete reaction, or impurities in reagents. Next, indeterminate or random error arises from random events that are not necessarily under the control of the experimentalist. It causes data to be scattered more or less symmetrically around a mean value. It reflects on the precision of the measurement. It also caused by many uncontrollable variables in physical or chemical measurements. Lastly, cross error. It is usually occurs only occasionally and may cause a result to be either high or low. For example, parts of precipitate is lost before weighing, or touching a weighing bottle with your fingers of the empty mass will cause a high mass reading for solid weight. It leads to outliers, result in replicated measurements that differ significantly from the rest of the results.
The bar graph show the volume of NaOH trial 1 until trial 4. From the data, trial 1 is 25.10 volume of NaOH, trial 2 25.15, trial 3 25.5, and lastly trial 4 26.50, which is trial 4 is outlier, gross error misread. We have two calculations, which is without correction and with correction. For without correction, the mean is 25.10 plus 25.15 plus 25.5 and plus 26.15, and divide by total trial, which is 4. We got 25.45 ml. And for with correction, calculation with correction is the mean 25.10 plus 25.15 plus 25.5 and divide by total trial 3. We remove the outlier for trial 4 and we got 25.10 ml.
Hi, Assalamualaikum. My name is Siti Muslimina binti Marusaman. So I will explain about the description of the error for example experiment. Description of the error, I will call it as cross error. In trial 4, the volume recorded was 26.50 ml, which is noticeably higher than the other trials. This suggests a cross error likely caused by human mistakes, such as misreading a period or reading the wrong value. So how to minimize this error? To reduce cross errors, we can first repeat the experiment and compare the readings. Second, use proper reading techniques such as eye level at the meniscus, and third, label data clearly to avoid confusion. And fourth, always ensure the use of correct and calibrated equipment. Hi, Assalamualaikum. My name is Siti Muslimina binti Marusaman. So we have already reached the end. To conclude, errors in experimental data are a normal part of any experiment. However, that doesn't mean we can ignore them. These errors, whether systematic, random, or gross, each affects the quality of results in a different ways. If they are not controlled, they can lead to inaccurate conclusions and unreliable data. That is why it is important for us to understand where does these errors come from, how these errors affects our measurement, and how we reduce these errors. By minimizing errors, we improve accuracy, precision, and overall trust in the result.